guys, today we are learning how to solve systems of equations by graphing. But before we do this, I want to talk about what is a system of equations. A system of equations is a set of two or more equations. So it might be something like y equals 3x plus 1 and y equals negative 2x minus 5. Okay, so we learned in a couple units back how to graph these, and the solution of a system of equations is the intersection point of the lines. So the solution of a system of equations is the intersection point of the lines. Okay? So when I ask you to solve a system of equations by graphing, we're going to find the intersection points by graphing. Okay? So again, a system of equations is when you have two or more equations using the same variables, so x and y. You can also have a and b or L and M, but most often you'll see x and y. The solution to the system is the point that satisfies all of the equations. This point will be an ordered pair, so parentheses x, comma, y, parentheses. When graphing, you will encounter three possibilities. Okay. So intersecting lines. So you've got three possibilities. You've got intersecting lines, so lines that actually do intersect. You've got parallel lines. What do we know about parallel lines from before? We know that parallel lines have the same slope. So that's the second type of situation that we have. And the third type is if you actually have two different lines that you think are different, but then when you graph them, they're exactly the same. Okay? And those are called coinciding lines or coincident. Okay? So this one, if we want the solution of the system, we've got one graph here in red and one graph here in red, and we would want to the point where the lines intersect. So what is this ordered pair? This ordered pair is 1, 2. So the solution of this graph is the ordered pair 1, 2. And those lines are intersecting. They're intersecting. They're intersecting. Oh, these are parallel. They have the same slope. Parallel. They have the same slope. So, back over here, I told you I would be kind of silly, so I'm trying. Okay, so if you look at this, we learned about parallel lines. They have the same slope, and look, they never intersect. That's one of the properties of parallel lines. They're parallel because they don't have the same y-intercept. They cross the y-axis at two different places. This one crosses the y-axis at -1, and this one crosses the y-axis at 2, but they both have the same rise over run, up 2 over 1, up 2 over 1. So they have the same slope, but different y-intercepts. And since the solution of a system of equations is the intersection point, parallel lines do not have an intersection point. They just don't. So the solution is no solution. So if you have parallel lines, the solution is no solution. All right. Now, what was the third type? Well, the third type was what? We talked about intersecting. We talked about parallel. Hey, come here. Come here. Yeah, come here. Come here. Say hi. This is my first guest appearance. Say hello.
Hey. I don't like this.
Okay, go. Bye. Say bye.
Bye.
Do you need something?
I see this.
Oh, okay. So the third type is lines that are actually the exact same. Have a good day. Okay. They're exactly the same. And you might wonder, well, how would I graph two lines that are exactly the same? Well, they get graphed right on top of each other. And since the solution is the intersection points, these two lines, the red line, if you look very carefully, and the blue line are exactly the same line. So they intersect all the time. So that means that the solution is infinitely many solutions. Remember, this type of situation, these lines are called coinciding lines. they have both the same slope and the same y-intercept. So they're exactly the same. Exactly the same. Sometimes when you're given a system, it's like that in disguise and you don't realize it. It's just in disguise. You will know once you solve for y. So back over here, these were parallel because they had the same slope but different y-intercepts. And that solution is no solution. That's one of my favorite quotes in math. The solution is no solution. So here, when you're actually the same line, it's infinitely many solutions. It is not all real numbers. It's infinitely many solutions. All right, so now this is an example, and it says, what is the solution of the system graphed below? So we have a system of equations graphed, and remember, there's three types of lines, of systems. They intersect, they are parallel, or they're the same line. What are these? These are intersecting. They're intersecting. So they have a unique solution right there. So what is that ordered pair? All right, we start at the origin. And it's over 2, so it's got to be this answer choice. And then it's down to, so this ordered pair is 2, -2. So the solution is answer choice 1. It's 2, -2. I hope that makes sense. Now, what about this one? Find the solution of this system. This is when it starts getting really real, where the context is no longer a graph, it's actually 2 xy equations. So if I want to find the solution of the system, I need to look at the graph. Now that's because we're doing graphing today. There's also other ways to do it. Elimination, substitution, you can even do a matrix method, okay? But we're talking about graphing right now. So if I'm giving you this one, that's in standard form. So we can graph this by, we have some options. We can find the x and y intercepts and graph it that way, or we can solve for y and graph it that way. We've learned how to do both ways. I wanted to go with this way just to get you more used to the x and y intercept method. Remember, when it's in standard form, oftentimes it's quicker to do x and y intercepts. Not always, not really on this one maybe, but I just want you to get more used to x and y intercepts. So remember, if I'm taking this first equation right here, and I want you to find the x and y intercept, remember to find the x-intercept. Let's start with the y-intercept. To find the y-intercept, remember you let x be 0. So what does y equal? When x is 0, y is what? It's 4. To find the x-intercept, we let y be 0. So I let that be 0, and I get 2x equals 4. And I divide by 2, so what does x equal? 2. So I can graph this line using these 2 points, and then just connect the 2 points. The second line is this, and I let x be 0. I get negative y equals 2. I divide by negative or multiply by negative. I get y equals -2. I let y be 0, and x is 2. So then I would just graph the ordered pairs. So 0, 4, and 2, 0, 0, 4, and 2, 0, and draw that line, okay? And then the other one was 0, -2, and 2, 0. So 0, -2 right here, and 2, 0, and then draw that line, and they're intersecting. So we have a unique solution. And where do those lines intersect? What is that ordered pair? It's 2, 0. So that is the solution of the system. We got 2, 0. Now you can check yourself. We think it's 2, 0. I mean, I'm fairly confident it's 2, 0. But the way you check yourself to see if you're right is you plug the point back into both equations. So I'm going to plug 2, 0 back into both equations. So I plug a 2 into the x and a 0 into the y. That's x, y. So 2 times 2 plus 0. Does that equal 4? Yes. 4 equals 4. Check. So now here, plug a 2 into the x and a 0 into the y. Does that equal 2? Why, yes, indeed, it does. So since it checks in both, we did a great job. We got it. The solution is indeed 2, 0. On to another one. Number 2. Find the solution to this system. Okay, now look at this system. That's in what we call slope-intercept form. So we very easily can see the slope and the intercept, the y-intercept. This is not in that form. So I want to not do, we could do x and y intercepts and do it that way, but I would like us to practice solving for y. It's a literal equation, solve for y. All of this stuff comes back because we've learned this all before, and you've got to remember these things. So let's solve this for y, so that then we have two slope-intercept forms that we can graph using slope-intercept form, using the y-intercept and the slope. So solving this one for y, you all should be very comfortable getting here. Now how did we get from here to here? What do we do? Well, we would add 2x, add 2x. So those would go away, and you get y equals 2x plus 1. Yes, you could write it as 1 plus 2x, but we're trying to keep in mind we want it in slope-intercept form, so it's mx plus b. Y equals mx plus b. So now I've got these two equations. What's the slope of that first equation? Well, remember, y equals mx plus b, where m is the slope, okay, and b is the y-intercept. So on this first equation, your slope is what? 2. Now because we're getting ready to graph, I want to write it as a fraction because it's rhymes over 1, so 2 over 1. And your y-intercept's -3. And the second equation, what's your slope? Your slope is 2 over 1, and your y-intercept is 1. So now we can graph those things. So remember, it's just a synopsis of what we just had. So to graph this line, we go to the y-intercept of -3, draw the dot, and then go up to, remember, up to over 1. So up to over 1 dot, and then draw your line. We've already learned how to do this, so don't forget what you know. Don't forget what you know. So we've got that line. Now the second one was this one, which is right here. Okay, so the slope is 2 over 1, and the y-intercept is 1. They have the same slope, but different y-intercepts. So the y-intercept is 1, up to over 1, boom, boom. Oh my goodness, they are parallel lines. So the solution of a system of equations is the intersection point. Is there one here? No. So the solution is no solution. The symbol for that is this. If you want to use that symbol, that's great. You do need to be aware of that symbol. Notice that the slopes are the same with different y-intercepts. If you recognize this early, you don't even have to graph it because you realize the relationship. So we check it. There's not a lot to check. Just make sure you set up your equations correctly, and we did. We did. Okay. What is the solution of this system? Which one? So how would we do this? Well, let's solve each one for y. This should be something you should be able to do fairly quickly. So how do I solve this first equation for y? I would toss this over and toss this over. So I get 3x. If I toss something over, I change the sign. So 3x minus 8 equals, tossing that over, positive y. So let's write it as y equals 3x minus 8. So that's the first one. That's me rewriting that. Okay, and then the second one, 2y equals 6x minus 16. Well, how would we solve for y here? We divide by 2 everywhere. So we get y equals 3x minus 8. Boom, 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 boom. There we go. Now, let's graph. Look at those. I don't even have to graph it. Are they the same? They're exactly the same. Exactly. On both of these, what's the slope on both? It's 3. What's the y-intercept on both? It's -8. They are the exact same line. They didn't look like it at the beginning, but they are. It was in disguise, like disguise, like you can't see me. But they are the same, okay? They're exact same line. That's called coinciding lines. So if they're the exact same line, so this and this, they intersect all the time. So it has infinitely many solutions. The answer choice number 4. Okay. So let's summarize. There are 3 steps to solving a system using a graph. Step 1, graph both the equations. You can use slope and y-intercept or x and y-intercepts. Be sure to use a ruler and a graph paper if you don't have a graphing calculator around. However, if you have a graphing calculator, you can do it on here once you get it in y equals. We know how to do that too. In y1, you put the first one. And y2, you put the second one. Second calc intersect, number 5. Enter, enter, enter. It'll give you the answer. Okay? Okay. All right. So do the graphs intersect? This is the solution. Great. Write the solution and then check it. I hope that makes sense. Enjoy. Oh.